So here you have the learning objectives for this session. The first one is going to be to understand the concept of database. Second one will be to gain some new knowledge on the concept of a relational database and why they are useful for data scientists. The third objective is to understand the concept of NoSQL databases, and finally we will reflect on the differences, advantages and disadvantages of SQL and NoSQL databases. An initial idea for database could be to understand a database as a system which is used to store data. Apparently, it makes sense, but this definition would be including, for example, this set of post-it notes, or imagine a box with a lot of purchased tickets inside. According to that definition, these two examples could be considered as databases because actually they are systems which are storing data. So we need to add a term that helps to reflect the degree of digitalization for the data that we are planning to store. So we should include the term computer to complement system in order to make the definition more comprehensive. But even including computer system for the definition of database, this is still incomplete because according with this definition, we could include a hard drive as an item that could fit with this definition. So we are close, but still we need to complete the definition. We should include that the computer system is going to be employed not only to store data, but also to organize this data in some way. So you can see now that this definition is much better and it fits pretty well with an spreadsheet, which is a simple example for a database. So the definition that we have now, a database is a computer system used to organize and store data, is good enough. But the following question is, why do we use databases? What is the reason because we need databases? Basically, we are storing data because at some point we want to make use of this data. So at the end of the day, databases store data that must be retrieved and analyzed later on. So it would be good to include the utility of databases into the definition. So here we have a comprehensive definition for database. A database is a computer system used to organize and store data that can be useful at a later point in time. Now we have a better understanding of what a database is. And we are going to introduce now the concept of relational database. Basically, in a relational database, we can find some rules on the structure, storage, and retrieval of data. Data is going to be organized and distributed into different tables that relate to one another. In a relational database, the data is stored more efficiently, reducing inconsistencies and making the process of retrieval much faster and easier to perform. The use of relational databases allows data analysts to turn raw data into useful, valuable, and actionable information, which is what we are looking for at the end. So we are going to understand much better the concept of relational database by using a simple example. Here you have a table with data from owners and their pets. And we are using a flat file database. This could be a simple spreadsheet. And here you can see some repetition of data to store the information. And we are here combining data from the owners and data from the pets. So maybe this is not the most efficient way to organize the data, especially if we want to add more information or when we start to do some queries. So in a relational database, we will be using different tables that connect each other in some way. In that case, we will be creating one table for the owner, which includes all the owner information, and we are creating another table with the pet information. As you can see here, we are identifying the owner with a code, basically an ID for the owner. And we are using this code in the table for pets. So now we don't have to include here all the information related with the owner. This makes the process much easier to manage and retrieve information, and especially when adding information. For example, if we want to change the phone number for one of the owner, we can do it only here, changing one cell. While in the flat file database, we should change 3 cells to update this data. So here you have a graphical example of relational database and the key features for this database. Basically, the data will be represented in the format of table. I mean, we can have different tables relating each other, but all data will be stored in tables. Relational databases deal only with the data and don't reflect any physical structure. This type of databases are good at providing information regarding metadata, and a key characteristic is that in the intersection of a row and a column, there will be only one value. This way to store and organize data in relational database provide the easiest way to handle the queries in this data. So the way we can manage a relational database is through the Relational Database Management System, RDBMC. The Relational Database Management System is the basis for the SQL language, the structure query language, which is a specific language used in programming for managing data which is held in relational databases. SQL language is particularly useful to handle structured data. It means data which reflect relationships between different entities and variables. Basically, the kind of data that we find in relational databases. So, in this type of management system, the data will be stored in tables. It means in collections of data which are related through data entries, and that basically consist in a set of columns and rows. Many famous database systems such as Oracle, Microsoft Access, of MS SQL use this management system, the relational database management system. Apart from the relational databases, we can distinguish other types of databases. Some of them are a little bit older, such as the hierarchical database, network database, and object-oriented database. But it's good that you know these different ways to store and organize data. In the case of hierarchical database, the data is going to be categorized in different levels, and this will be organized in what we call parent-child relationship. By using this type of structure, the addition of data elements will require a lengthy transversal through the database. Here you can see an example of hierarchical database. The IHER rank is university. In the second level, we will find two different categories, departments and administration, and for each of them, we can find a third level. In that case, for departments, we have the students who belong to this department, the faculties who belong to the department, or the resources that belong to the department. Network databases are quite similar to the hierarchical databases because data is also categorized in ranks or levels. The main difference is that now the child records, as you can see here, students, faculty, or resources, are given freedom to associate with multiple parent records. As you can see here, for example, faculty is associated with two parent records, departments and clubs. So as a result, a net of database files linked with multiple threads is observed in this type of database. The main problem of this database is if we want to change the structure because the complexity is quite high, and this makes these kind of databases structurally dependent. Other type of database is the object-oriented database. In that case, the information is going to be stored in a database which is represented as a set of objects. Here in the example you can see 4 different objects: person, students, address, or professors. So here you have the main object, which is person. That could be two types, students or professor, and we can add different features, like for example the place where they live at. The good thing in using this kind of database is that the object can be easily called without any difficulty. So keeping in mind that there are other types of database apart from the relational database, the main competitors for the relational databases are the NoSQL databases. So basically, this kind of databases don't use the SQL language. The NoSQL databases are normally used for large sets of distributed data. They have shown to be quite efficient in analyzing large size unstructured data. And that's the reason because they are considered as a very good option when dealing with big data. The fields to organize the data into this type of databases are not necessarily standardized, and they can be organized in different ways. These databases are good at storing nested values. Mainly, the NoSQL databases do offer more flexibility, and they are usually better for scalability. And basically, the main difference with the SQL or relational databases is that this data is not organized in tables following columns and rows as we store the data in the relational databases. We can distinguish different types of NoSQL databases. The first one is the document store. In this kind of database, the data and metadata are stored hierarchically in XLM or JSON based documents inside the database. Here you can see a graphical schema to show how the document store database looks like. Other classical model of NoSQL databases is the key value store. This is the simplest way to produce a NoSQL database. In that case, the data is represented as a collection of key value pairs. Actually, you already know how to create this kind of database by using dictionary in Python. The third type of NoSQL database is known as white column store, and the main characteristic is that the related data is stored as a set of nested key value pairs within a single column. And the last type of NoSQL database is the graph store. In this type of databases, the data will be stored in a graph structure, which shows graphically the relationships between data properties. Here you can see a quite easy example to understand the concept. Imagine this as a way to store data that represents who follows who in social media such as Twitter or Instagram. So nowadays, the main options in terms of databases are the SQL and NoSQL databases. And both are some pros and cons. Basically, the relational is more easy to use and set up. Its use is more extended. This makes this database to be more universal and compatible with many other different tools. They are good at high performance workloads, but however they are quite time consuming to understand and design the structure for the database. And maybe the main difficulty is to scale, to make it bigger when we have a huge amount of data. However, the NoSQL databases are pretty good at design different models. In general, they can be faster than SQL and they runs pretty well on the cloud. However, the main cons are that the technology is still maturing and sometimes they can have a slower response time. And maybe the main cons is that they are unsuited for interconnected data. So here in that table you can see a comparison of NoSQL and relational database in terms of performance, reliability, availability, consistency, data storage, and scalability. As you can see, the relational databases are much better in terms of reliability and consistency of the data, while NoSQL databases are better to deal with huge amount of data and allows scalability at lower prices. So here you have some main conclusions for this session. It's important that you have clear that a database is a computer system used to organize and store data that can be useful at a later point in time. The concept of relational database in which data is organized into multiple tables that relate to one another. And the important thing is that the data in these databases is represented in the form of table only. The relational database management systems are the basis for the development of the SQL language, which is a programming language particularly useful in handling structured data in managed relational databases. The alternative to the relational databases are the NoSQL databases, which are databases that don't use the SQL language. And they are quite efficient in analyzing large amount of unstructured data, which is characteristics of big data. And finally, you need to keep in mind that different databases will have different benefits and drawbacks that must be assessed. They must be evaluated by the organizations in order to decide the best option depending on the data types that the organization need to manage and its business needs. That's all from me. Thank you so much for your attention. I will see you all in our next synchronous session. Goodbye.